Hello, everyone, and welcome. We're diving into a complete ICAI revision of unit and batch costing. But listen, we're not just going to skim through the concepts. Oh no, we are going to expose every single common trap that ICAI loves to set in the exam so you can walk in there completely prepared. Let's get you ready to ace this.
Okay, let's kick things off with a classic exam-style curveball. Look at this. Monthly demand is 500 units. Carrying cost is 1 rupee per unit times per month, and the setup cost is 60 rupees. What's the EOQ? Now hold on, if your first instinct is to just grab those numbers and plug them straight into the formula, you've just fallen for the single biggest trap in this entire chapter. This is exactly where so many students lose easy marks. But don't you worry, by the end of our session today, you'll spot this trap from a mile away.
All right, first things first. Why do we even have all these different costing methods? I mean, why not just have one simple way to do it? Well, the answer, it all comes down to what kind of products a company is making.
Just think about it for a second. On one hand, you've got industries that do job work. We're talking about building a massive, one-of-a-kind ship or crafting a custom piece of furniture. Every single order is unique. But on the other hand, you have process industries. Picture a cement factory or a chemical plant. They're just churning out thousands upon thousands of identical, totally indistinguishable products. It just wouldn't make sense to use the same costing method for both, would it? And that's exactly why we need different approaches.
So for those industries that are mass-producing identical items, we use this simplest, most straightforward method there is. And that brings us to Section 2, the basics of unit costing. Unit costing, which you might also hear called single or output costing, is perfect for when every single unit that rolls off the production line is exactly the same as the one before it. We're talking about industries like paper mills, steelworks, or breweries. Since every unit is identical, the cost for every unit is also identical. And the formula? It's as simple as it gets. Just take your total cost of production and divide it by the number of units you made. That's it. The final result is usually laid out in a detailed cost sheet, which is super useful because it shows the cost per unit at every stage of production. So, how do we actually get that total production cost figure? Well, it's a pretty clear-cut process. For all the materials used, we collect the costs from the material requisition notes. For the labor, we look at the time cards. And finally, for overheads, we absorb them using an appropriate overhead rate. You just add those three up, materials, labor, and overheads, and bingo, you've got your total production cost. Simple and super effective for this kind of setup. Okay, but what if you're making identical items, but not in some continuous, never-ending stream? What if you produce them in specific groups or lots? Well, that brings us to the fascinating middle ground, batch costing. Now, batch costing is technically a form of job costing, but it has a really important twist. Here, the job isn't a single unique product, it's a whole batch of identical units. A great example is a pharmaceutical company making a batch of, say, 10,000 tablets, or a bakery making a batch of 500 biscuits. The most crucial point to remember here is that we first calculate the cost of the entire batch. The batch itself becomes our cost object. It's only after we have that total batch cost that we divide it by the number of units to find the cost per unit. Now, here's where it gets really interesting. Batch costing basically exists to solve a fundamental economic puzzle, a trade-off between two big costs. See, if you decide to produce in really big batches, you don't have to set up your machines very often, which is great because your setup costs go way down. But now you're holding a ton of inventory, and your storage and holding costs are going to go through the roof. On the flip side, if you produce in tiny little batches, your inventory costs are nice and low, but you're constantly stopping and starting the machines, so your setup costs just skyrocket. It's this constant push and pull that we need to balance. So how on earth do we find that perfect balance, that sweet spot, that ideal batch size where our total cost is as low as it can possibly be? Well, that brings us to the main event of this chapter, calculating the economic batch quantity, or EBQ. And let me tell you, this is a massive area for exam questions. And here it is, the formula you absolutely, positively have to know. EBQ equals the square root of 2 times D times S, all divided by C. It looks pretty harmless, right? But as we saw right at the beginning, the devil is hiding in the details of those letters. Okay, let's break this down and please pay close attention because this slide is incredibly important. D stands for annual demand. This is ICAI trap number 1. They will give you monthly or quarterly demand just to trick you. You must, and I repeat, must multiply by 12 or 4 to get the annual number. S is the setup cost per batch, and that's usually given to you straight. Now, C is the carrying cost per unit
per annum. This is trap number 2. They'll give it to you per month or as a percentage. You have to convert it to an annual per unit figure. See, the formula is designed to balance annual costs. If your inputs for D and C aren't annual, the formula spits out a totally wrong answer. Get D and C wrong, and you've lost all the marks for the question. This is the number one reason students mess this up.
Let's see this in action with illustration 5 from the material. We're given a monthly demand of 500 units. So what's our very first step? Annualize it. D is 500 times 12, which gives us 6,000 units. The carrying cost is given as 10% per annum on the unit cost of 20 rupees. So C is simply 10% of 20, which is 2 rupees per unit per annum. Now we can finally plug those correct annualized values into our formula, and we get an EOPQ of 600 units. See? It's all about getting those inputs right before you even think about calculating. And here's the other common twist, which comes from illustration 6. The annual demand is given correctly as 48,000. No trap there. But look at the holding cost. 1 rupee per bearing per month. What do? You guessed it, we have to annualize it. C becomes 1 rupee times 12, which is 12 rupees per unit per annum. Once you've made that crucial conversion, the rest is just simple math, and it leads you to an EOQ of 2,400 units. I'm telling you, always double-check the time period for D and C. Now here is another critical little rule that ICPI loves to test, and this comes from illustration 7. Sometimes they'll ask you for the number of setups needed for the year. The formula is easy. Annual demand divided by EBQ. So in this example, 50,000 divided by 7,071 gives you 7.14. Now your brain might want to round that down to 7. Don't do it. You must always round up to the next whole number. So in this case, 8. And why is that? Well, think about it logically. You can't perform 0.14 of a machine setup, right? To produce all the units you need, you have to run that machine an 8th time. It's a small detail, but it's a mark winner. Okay, great. We've totally nailed the EBQ calculation. Now let's just zoom out for a moment and really solidify our concepts by comparing batch costing with its parent method, job costing. This is a very common theory question, so knowing the exact differences is key.
This table sums it up perfectly. The easiest way to think about it is this. Job costing is for one-of-a-kind products, where the job itself is the unique thing we're costing. Batch costing, on the other hand, is for many-of-a-kind items, where the entire batch is what we focus on first. The absolute key takeaway is the cost unit. Are we costing a specific, unique job, or are we costing a whole batch? Getting that distinction right is everything for the theory questions. All right, we have covered all the core concepts. Now let's pull everything together into a final, rapid-fire revision checklist. This is to make absolutely sure that all this crucial info sticks in your brain for the exam. Let's do a super quick recap. Unit costing? That's for identical mass-produced stuff, like cement. Batch costing? That's for identical items, but made in specific lots, like medicines. And EBQ? That's our magic number, the perfect batch size where your combined setup and holding costs hit their absolute lowest point.
Okay, this is it. Let's lock this knowledge in with your final hit list for the exam hall. Number 1, always convert demand, D, and carrying cost, C, to annual figures. Number 2, pay very close attention to whether the carrying cost is given as a percentage or a flat amount. 3, when you calculate the number of production runs, you always round up. And finally, number 4, read the question carefully and don't confuse the cost per unit with the total cost of the batch. These 4 points right here will save you a world of pain and a whole lot of marks. And we'll finish up with a little something to chew on. We've mastered the basics for sure, but what if a problem, like some of the practical problems in your study material, adds another layer of complexity? What if you have semi-variable overheads that actually change when you hit different production capacities, like 50% or 75%? How would you factor that into calculating the total cost for a batch? That's the next level of thinking. Give it some thought. Thanks so much for joining me, and I wish you all the very best for your exams.